Okay, everybody, we are going to take a look at the review for division. We have been working 2 solid weeks on division. At this point, the students have a lot of strategies. We are taking our test Monday, November 25th, and we have used a number line to help us with dividing fractions. We have used a calculator, and we have used our good old-fashioned paper and pencil and notes. And I just want you to know that we take notes in class. So if your student does not have a journal and are not taking notes, that could be a problem. So make sure that they are putting notes in their journals, because we have done how to use a number line to divide fractions. We've done a couple of those problems. We have talked about the standard algorithm, which is the algorithm that we learned when we were younger, which is just keep, change, flip, which we'll talk about that in a minute. We've done a little bit of review on how to rewrite mixed numbers as improper fractions and improper fractions as mixed numbers. We've done several practice problems on this. We've talked about different ways to represent number sentences, and we did a lot with equivalent fractions. So at this point, 2 weeks in, the students should have a good understanding of fractions and how to divide them. So in this video, we're going to do just a couple practice problems. I am going to be using my document camera, but I'm also going to use a calculator and the number line, just because they should know more than one way to solve a problem in case they get stuck. Okay. So we're going to do just a couple where they have to divide mixed numbers. So for example, if we have the problem 1 3/4, and we want to divide that by actually, you know what? Let's make this 2. We'll make it 2 3/4, and we're going to divide by 1 1/4. Now, to be honest with you, one of the easiest way to do this would probably be with a number line. If the students are using the standard algorithm, they have to walk through several steps. First step is they need to rewrite these mixed numbers as improper fractions. Okay, so rewrite mixed numbers as improper fractions. This is something they learned in 4th grade and 5th grade. So we don't really teach this skill in 6th grade, but we do review it, and it's definitely something they should know how to do. This shouldn't be new learning for them. So if they're having trouble rewriting these mixed numbers as improper fractions, the number line may be the way to go. I'm going to go ahead and do this because we have been practicing it in class. So we talked to the students about 2 3/4 is the same thing as 2 groups of 4. So the denominator tells us the parts. So this would be the same as 2 groups of 4. Okay, which is 2 times 4, which is 8. And then we look at this number at the top. This is our leftover. Okay, that's the leftovers. Okay, what doesn't make a group. So 2 groups of 4 is 8, and then this is the leftover. We need to add that in. Okay, we need to add in the leftovers. The denominator stays the same always because we're not changing the part. It's just we're rewriting it as a fraction greater than 1. So this would be 11/4. Okay, so we're done that one. Then we do the same thing over here. We take the larger number, which tells us that we have one group of 4. That's what that's saying. This is one group of 4, which is 1 times 4. And then we're going to add in the leftovers. So in this case, we're going to add this in plus 1, and that's going to be 5/4. Okay, so this is 5/4. So this is step 1, and this is hard for some of the students, I've been noticing. Okay, so if they can't write a mixed number as an improper fraction, they may be better off using the number line, which we're going to do in a minute. If they can get a handle on this strategy, rewriting them as mixed numbers or improper fractions, this is the better strategy. Okay, so here we go. We got 3 steps: keep, change, flip. All right, we got to keep the first the same. We're not going to change it. The second thing is the change, and that is the sign. We're going to change this to multiply. And then our very last step is we're going to, and this is the part they're all forgetting, This is the big one. We need to flip this. We're going to use the reciprocal. That's what it's called, reciprocal. So the reciprocal would be the numerator and denominator would just be flipped. So we're going to rewrite this as a multiplication problem. So we're using multiplication just to make it easier. Keep 11/4 the same, change this to a times, and then flip this fraction. This is the part they're all missing. They're forgetting to do this, or they're flipping the first one. It's always the second one. All right, once we get to this point, we just multiply straight across. 11 times 4 is 44, and 4 times 5 is 20. Now, this is another problem they're running into. This is a very big number, and they are not able to find like if it's a multiple choice, 44 over 20 may not be there. That is because we need to simplify. Because we changed these mixed numbers to improper fractions, we kind of have to put it back into that form. Okay, so we can do a couple things with this. One of the things where I'm helping them understand is that we can divide by a common factor. We can simplify this. And I just happen to know that 4 times 11 is 44 and 4 times 5 is 20. So I could just simplify this by dividing it by 4, numerator and denominator, and that would give me 11/5. This would probably be one of the multiple choice questions. So this would be the simplified version, 11/5, or we can turn it back into a mixed number. How many 5s make an 11? So I can ask myself, how many 5s make 11? 2, right? So I can do 2 times 5. 2 times 5 is equal to 10. Okay, 2 times 5 is equal to 10 with 1 left over. That would be my 1/5. There's that leftover. Okay, so either of these answers would be appropriate. They could use either one. I tell them it's okay to leave it in fraction form. All right, now let's take a look at this problem on the number line. Now this was a lot of math. Okay, so there's a lot of steps. So if your student struggles with following steps, because my daughter, when she was in school, she had trouble following steps, the number line may be easier for them. All right, so what I'm going to do is just minimize this, and I'm going to pop on over to the number line, and we're dividing 2 3/4 by 1 1/4. So I know I need fourths. So I'm going to come over to my fraction and that number line, I'm going to make it into fourths. Okay, and then I know that my greater number, the number that I'm dividing by into, the starting number is 2 3/4. So let's find 2 3/4. Here it is. Okay. There's 2 3/4. I even tell students they can circle it, box it, whatever. That's where we got to get to. Okay, now, what are we counting by? We need to count by 1 1/4, which is the same thing as 5/4. So 1 whole plus a fourth. So they can use the number hopper, and they can go, all right, 1 1/4, right? So I know I can make one whole group. There's my 1 1/4, right? And if I do that a second time, you can see I'm a little short, right? So here's my 1 group, here's my 2 group, there's my 2 wholes. So I know I can make 2 whole groups of 1 1/4, and then I have some left over. This is the part I have to figure out what's left over. So the students know to make another group, because if I skip count another group, I'm going to go past that. But then I can look at it and go, all right, well look, here's a part, look at the number line. See how it's divided? We're going to take that extra piece that we just added on and see how much of it do we need. Well, it's 1, 2, 3, 4, 5. I can take this bar and break it into 5 parts. I'm only using 1. I'm only using 1 of the 5. There is the leftovers. So there's 2 1/5. So much easier than all of these steps. This is why sometimes the standard algorithm isn't really the best option. Okay, so just know that it's totally okay for them to use this strategy, but they have to follow several steps. Break out the number line, a little bit easier. Okay, I've been encouraging them to check with a calculator. All right, so 2 3/4 divided by 1 1/4. Desmos doesn't like mixed numbers. They want fractions. Desmos doesn't work with mixed numbers. So they want to use the calculator, they are going to have to know how to turn the mixed numbers into improper fractions. So let's do that. 11/4 divided by 5/4. All right, so 11/4. And then I need to put my cursor on the outside of the number because I'm taking this whole number and I'm dividing it by 5/4. Okay, so it looks a little weird. It's a stacked fraction. So 11/4 over top of 5/4 because this right here is a division sign. It is just a fraction bar. And look what our answer is, 11/5. And that's exactly what we got. 11/5. Remember how I told you Desmos doesn't like mixed numbers. 11/5, which is the same thing as a decimal 2.2, but we're not doing decimals right now. So I would encourage them to leave it in fraction form. Now, what if they do that keep, change, flip? Okay, what if they do that keep, change, flip strategy? Keep 11/4, change it to times, and then flip it to 4/5. Let's show the answer that way. All right, 11/4, keep, multiply, flip, 4/5. Look, same answer. Okay, so students have multiple strategies. The algorithm, a number line, which this one was by far the easiest, even easier than a calculator, and then the calculator. Okay, so they should be able to pick one of these strategies to solve. All right, we're going to do one more. I'm going to do one more. We're going to do, let's do one where the denominators are different. That's an important one to do, when the denominators are different. Okay, where's my pen? Okay, so we're going to do, excuse me, I have clear my throat. Okay, what if we have 3 3/4, and we want to divide that by 1 1/2. Now this time the denominators are different. This one time the denominators are different. Okay, same thing. If we want to use that standard algorithm, we need to rewrite the mixed numbers as improper fractions, because in order to do the keep, change, flip strategy, we need fractions. Okay, so this is 3 groups of 4. Okay, so that's step 1, 3 groups of 4. I'm not going to write it out this time. 3 groups of 4, 3 times 4, and that equals 12, plus the leftovers. Okay, plus the leftovers. Plus, so I need to add 3 to that. All right, so that my new fraction, or my new representation, instead of 3 3/4, 15/4, which is the same thing. We just don't go around saying I have 15/4 of something. We say I have 3 3/4. Okay, now this one, gotta do the same thing. 1 group of 2. 1 group of 2 equals 2. And add in the 1. All right, so that would be 3. 3 halves. 3 halves. Again, keep that division sign. Okay, so all we did is rewrite the problem. Okay, that's all we did is rewrite the problem using fractions. We haven't even started the keep, change, flip yet. All right, keep the first fraction the same. 11/15. Change the division to multiply. Flip the second fraction. Okay, now that we're in this form, we just multiply straight across, but we are going to have to simplify just like we did on the first one. All right, 15 times 2 is 30. 4 times 3 is 12. Then we can simplify. A couple things we can do. First, we could maybe make this number a little bit smaller. If I don't want to do how many 12s are in 30, I can think about what common factor, what can I count by? What can I count by? And land on both 12 and 30. Okay, that's what we're asking ourselves. What can I count by? So think about it. You know, I can count by 5s and land on 30, but I can't count by 12s. I can count by 4s and land on 12, but I can't count by 4s and land on 30. What about 6? I know that 6 times 5 is 30, and I know 6 times 2 is 12. So 6 is a common factor. Again, if they know their multiplication facts, that will be a lot easier. Okay, so now I'm just simplifying. and this would be 5/2. Now, we can leave it in this form, or we can rewrite it. How many 2's make a 5? 2. 2 times 2 is 4 with 1 left over. 2.5. They mean the same thing, so we could do either one. All right, again, lots of steps. Let's go into the number line tool. All right, now the number line tool for this one is a little bit trickier, but not by much. In order to do the number line, we have to have the same denominator. So if I'm doing 3 3/4, divide it by 1.5. In order to use the number line, these two have to be the same, but this may be a little bit easier for the students because most kids know how to rewrite a half using a different denominator. So 1 1/2 would be the same thing as 1 2/4. So if I want my fourths to be the same, 2/4 is the same as 1/2. So now we know we're going to make sure our number line is in fourths, which I already have it in fourths. And instead of using a half, we're just going to use the 1 2/4, which is the same thing. All right, so 3 3/4. I'm going to come over here and just clear the board. All right, 3 3/4 divided by 1 2/4, which is the same thing as a half, 1.5. All right, so 3 3/4. Here's 3/4. See, watch how easy this is. Use the number hopper. All right, I need to make 1.5 or 1 2/4. Drag it out. Okay, there's my 1 2/4. Now I'm just asking, how many 1 2/4 can I make with 3 3/4? I'm just using multiplication. That's all I'm doing is counting up. All right, duplicate, duplicate. All right, so we got 1 whole group, 2 whole groups. That's 2. So I know I'm going to have 2. Now let's figure out the leftovers. So look, if I take that last hopper and I divide it up by the number line, see how I'm just using the number line to divide the pieces? This is 1, 2, 3, 4, 5, 6. I can divide this into 6 parts, but I'm only going to use the first 3. 3 out of 6. And guess what 3 out of 6 is? A half. Okay, so 2.5, which is exactly what we got when we used our standard algorithm. 2.5 or 5 halves, okay? But again, 2.5, 2 3 6, same thing. All equals the same. They just have to get used to knowing that if their answer, like if it's a multiple choice and 5 halves isn't one of the choices, but 2.5 is, or if they get 2 3 6, but 2.5 is one of the choices, they need to know how to flip it back and forth. Okay? All right, now calculator. Last one. Remember, Desmos doesn't like mixed numbers. So if you use the calculator, you are going to need to use improper fractions. 15/4 divided by 3 halves. Now for this we can leave it. The calculator can actually divide it. Our human brains have a hard time dividing fractions, so that's why we convert it to multiplication to make it easier. All right, 15/4. And I need to put the cursor on the outside. Divided by 3 halves. 2.5. 5 halves, 2.5. Now let's use that keep, change, flip. 15/4 times, now flip it, 2/3. Oh, sorry, 2/3. 2.5, same thing, okay? All right, so hopefully this helps. Students should have an understanding of this at this point. We've been doing a lot of practice with this. Now listen, if it's not a mixed number and it's already in fraction form, then they can just use that keep, change, flip. So literally, like if it's just a fraction, for example, if somebody's, if we do 3/4 divided by 1/5, okay, that you don't have to do the whole mixed number and proper fraction thing. We just do keep, change, flip. So 3/4 times 5/1. I feel like anytime it's a fraction and a fraction, that's just easier to use the algorithm. But if it's mixed numbers, it might be easier to just use the number line, okay? Because again, once you have it in fraction form, you can just use the keep, the change, and the flip strategy, and that will give you the answer. And again, 15/4, we can leave it that way, or we can say 3 3/4. Okay?